is Alex BALZI, and I'm a research fellow at the University of San Marino. In this presentation, I'm going to show you the Pavement Management System procedures and Geographical Information System tools developed and used in the Republic of San Marino. In detail, the presentation contains the following topics: a short introduction on the principle of PMS for local road administrations, the objective achieved thanks to the use of PMS in the Republic of San Marino. Then I'm going to show you the GIS data management tools for the selection of road information data and their implementation on road database. And finally, the priority rating and maintenance planning tools used to support the decision making. The use of systematic process based on PMS can help the road administration agencies to make maintenance rational, objective, and cost-effective, even if PMS concepts don't change moving from different contexts. Local administrations need of customized tools that substantially differs from those adopted by highway and airfield administrations. Since local road authorities generally manage a wide and heterogeneous road network with limited budget, human resources, and tools, in this context, the implementation of PMS with GIS can give great benefits due to the representation of raw data on maps. Moreover, customized GIS-based tools can be created to increase data collection and analysis process. The research programs aims to establish a tailored and sustainable PMS for local road administrations, which support and standardize survey activities, ranking maintenance priorities, and identify the cost-effective strategies. To obtain understandable output results, such as thematic maps, to create a GIS database of road information, to implement customized GIS-based tools for analysis and multi-year planning, and finally, to define technical methods, design documents, and quality control procedures. The San Marino Road Management System was designed as a circular sequence of connected phases, in which every activity outcome is the starting point for the following one. On the left, in this slide, you can see the functional phases, while on the right, the activities to be performed in each phase respectively. In detail, the process identifies two operative levels, network and project level. The first one, highlighted in red in this slide, is related to the monitoring of pavement condition and evolution over time of pavement distresses on the entire road network. The areas with low performance or condition are ranked in priority maintenance list according to technical limits, while at the project level is performed the design of maintenance applied to the priority areas. The design considers distress types, repair methods, environmental issues, budgets, and service life. The San Marino road network was implemented on GIS database and divided into networks and road types, then in homogeneous sections with same characteristics, and finally in sample units. The sample units are wide as a road lane and have a maximum length of 0.5 km for urban roads and 1 km for extra-urban roads. Each road sections and sample units were identified with a unique alphanumerical code to avoid misleading identifications and analysis in the GIS database. The information uploading, road survey, and monitoring of pavement conditions were carried out periodically. On the left of this slide, you can see the road network's classification according to hierarchy, functional and traffic levels, while on the right you can see the road type classification by the urban and extra-urban context. For the evaluation of pavement condition, a rating system was defined considering standardized visual inspection method. The Pavement Condition Index, PCI, was calculated on several pavement segments to create a reference scale and to address the classification of sample units by comparison. To support road maintenance staff, a GIS service was created for mobile devices for the real-time monitoring and reporting of road emergency on restricted areas. For the evaluation of pavement roughness, the International Roughness Index (IRI) was measured on specific routes using a selected application for smartphones. The prioritization of maintenance was performed using an expression that considers the following technical factors: the PCI values, the traffic level factor (TF) based on average daily traffic values, road network hierarchy and function factor (FF) based on network types and road functional classification, strategic function factor (SF) based on commercial or tourist roadways and places of public interest, historical maintenance and rehabilitation factor (MH) based on annual costs of previous maintenance works, and finally the roughness condition factor (RF) based on IRI values. Note that the previous factors are parameterized with appropriate weights according to a relative rating value that ranging from 0 to 100. The priority index, PI, was defined as a number ranging from 100 to 0, where 100 means the maximum priority, while 0 means no repair or preventive maintenance. The PI is calculated if PCI or IRI values exceed the respective safety threshold, PCI lower than 55 and IRI equal or greater of 6 for primary roads and IRI greater or equal to 10 for local and secondary roads with operating speed lower than 50 km per hour. All the priority sample units have to be investigated at the project level to identify the specific maintenance strategy for road network and for each area to be repaired. The multi-year planning was performed using custom GIS tools and Python routines to graphically see the current pavement condition and its evolution over time on the map. As you can see in the following slide, it's possible to create different scenarios on the map, thanks to comparing the different maintenance strategies applicable to the road network. In these pictures, it's shown the pavement condition of road section after 5 and 9 years from the carry-out of temporary and long-lasting repairs, respectively. In conclusion, the research project has allowed to create an overall scheme of actions to be performed using specific tools and reference documents for an efficient PMS for local road administrations. The use of GIS tools was useful for the standardization, digitalization and managing of road maintenance data, and to support maintenance priority rating and multi-year planning analysis. Even if the greatest benefits are gradually obtained over time, the application of PMS has already allowed to gather positive experiences, increase quality standards, and establish good practice. Finally, the future developments of the research program will focus on the implementation of road accident analysis. Thanks for your attention.